Okay, today I'm going to show you how to do a curve, how to draw a curve. Now, usually when you want to draw a curve, okay, when the question gives you a table, and then in the past, when you do the linear graph, you always draw a cross in the center, right? Okay, but this time round, every time when you want to draw a graph, okay, you have to read the question and see. Okay, for example, like this one, the h, you want to draw a graph which is h against the mass. Okay, so the h starts from 0 to 70. So if we were to put in the center, the negative portion is not used. Okay, and then same for this mass also. When it starts from 3, if we were to start from 0, I mean we draw at the center, that means the negative portion is not used at all. So what we do here is we must plan. We see, okay, it's all positive, and then the question tell you to use 2 cm to represent 10 days and then 4 cm to represent 1 kg. So this is our graph paper. We will draw, because we are going to only show the positive quadrant. Okay, both x-axis and y-axis, vertical axis and horizontal axis are both positive. Okay, so what we're going to do is, okay, because I'm using this thicker pen to show you, okay, you're supposed to use 2B pencil. Okay, I use this thicker one so that it's clearer for you, otherwise it's quite difficult to see. Okay, so we draw a vertical line, a horizontal line. Okay, so the vertical line actually represent the mass. Horizontal line represent T days. Okay, so you are told to use 2 cm to represent 10 days. So 2 cm, 2 cm, 2 cm, and so on. So we have our 10, 20, 30, 40, 50, 60, and 70. Okay, so what about the vertical values? Okay, vertical values 4 cm to represent 1 kg, but it starts from 3.35. So if we were to say 1, 2, 3, 4, and then if there's a case, we may not be able to accommodate everything. So what we're going to do is maybe you want to start from 2. Okay, so can I just put this as 2, 3, 4, okay, 5, 6. Okay, so that is the mass in kg. Okay, this is question 1. Okay, question 1, this is mass in kg. So you have to know that because there are 20 squares for 1 unit, so that means every 2 square is 0.1. Every 2 square is 0.1 for the vertical axis. Okay, so now we're going to plot the points. Okay, starting, okay, because from 2 to 3 to 4 to 5 to 6, they are all uniform. Okay, 4 cm, 4 cm, 4 cm. But from 0 to 2, it is not uniform. So you're going to use a jagged edge, okay, jagged line to represent that from 0 to 2, it is non-uniform. So we don't read anything from here. Okay, so now we're going to plot the points from 0 and 3.35. So 1, 2, 3, 5. Okay, 3.35, then 7 with 3.1. So 3.1 is 1 is here. Okay, 7 and 3.1, 14 and 3, 14 and 3. So 3 is here, 14. Okay, and then 42 with 3.95. So 4 is here. 42. So 4 is here. So 3.95 go down 1. square. Okay, one small square. Okay, no choice. Okay, so we are going to join them by a curve. Since we don't have curve ruler, okay, so what we're going to do is, maybe for you, you use pencil to draw it first. Okay, after you draw it ready, then if it's okay, then you use a 2B pencil to draw it. Here I am going to turn it this way and draw. I'm going to use freehand drawing. Not very nice, okay? It's freehand drawing. Okay, so something like this. Okay, so this is a graph that we get. Okay, then we are going to answer the question. Okay, this is the part A. So use your graph to estimate the mass of the baby after 63 days. 63 days. Okay, you take note here. The question always say, answer the whole of this question on the sheet of graph paper, which means everything on graph paper. You cannot take another piece of foolscap paper and write it. Okay, so everything on graph paper. So first, okay, we see that, okay, we have drawn this whole thing already. This bottom, not so much space. We can write our answer at the top here. Okay, so we're going to write our answer here. Okay, so B part 1. B part 1. So what is the mass after 63 days? So 63 days. Okay, draw a vertical line. To see, you can draw a dotted line. You use a pencil better, okay? Mine is because I am showing you, I need a marker, so marker is clearer for you to see. So this is not so easy to draw. Okay, so this is for B part 1. Okay, then part 2, when the baby's weight was least, you can see that here, this is, okay, here, see, so these two have the same height, so the position, it should be in the middle. So you can read it as 17 or 18, up to you. Okay, or 70.5 also can. Okay, so 17.5. Okay, so this is part B. B part 2. Okay, then the third one is, what is the weight at the birth weight? Okay, birth weight is this one. Okay, you can see from table is 3.35. So we draw a horizontal line. Okay, draw a horizontal line. Okay, and touch here. Okay, so this is what we're getting. Okay, and then next is by drawing a tangent, find the gradient at 7 or 3.1, or some of you, I ask you to do it at 49 also can. Okay, whether you draw here or draw here, because here I find that it's quite difficult to draw. Okay, but because, okay, how to draw a tangent, okay, I'm going to show you a video to draw tangent. Okay, so over here 7, we look for the point 7. 7 is actually this point. Okay, this point. So what you do is, you take the point which are, these 2 points are closest to this one, and then the distance are equal. So what you do is, you join these 2 points up and then push it, and then you can see that this portion is bigger gap, this portion is narrower, so I tilt it more towards this side, so that both sides are balanced. Okay, so this is the tangent that I'm going to draw. Okay, draw a line long enough so that you can see clearly. Okay, you may want to take this point, and then maybe another convenient point will be, okay, which point is good? Okay, maybe this point. Okay, maybe this point. So we see this point is 45 and 2.15. Okay, 2.15, and then this one is -9 and 3.5. Okay, 3.5. Okay, so we can draw this triangle. Okay, please use pencil to draw. Okay, here and here, 2.15. You form a right angle triangle here, so that this length and this length you can do calculation later. Okay, so next we are going to write all the answers on top there. So now we have finished with we want to find the gradient. Okay, gradient means I want to find how is this length. Okay, let me show you how is this length compared with this one. Okay, this line slant this way, so gradient is going to be negative. There are two ways to calculate the gradient. One is you use this y minus this y, divide by this x minus this x. That is one way. Another way is I find the two lengths, and then the two lengths, the ratio. Okay, I can see the ratio, what's the ratio, and then I will just put negative to the ratio. Okay, because the line slant this way, so it has negative gradient. So what I'm going to do is I'm going to say put 2.15, 0.025. Okay, so the next part 2, please organize your work clearly. Okay, don't keep writing until very big, then after that, oh, not enough, arrow here, then after that, oh, this part not enough, arrow, until the whole place is so messy. Okay, so plan before you write. Okay, next one, what does this gradient represent? So you see the gradient means I'm having this gradient, right? So you can see that the weight is decreasing when the time goes up. Okay, time from a smaller time to a bigger time, whereas the weight from a bigger weight go to a smaller weight. So that means there is a reduction of the baby's mass. Okay, so I say that how do I explain? So I say, what does the gradient represent? So I say that it's on the 7th day. Okay, on the 7th day, the mass of baby reduced by 0.025 kg per day. Take note, I already say reduce, so I don't put negative here. Okay, and then this is kg. Okay, kg per day. Only at 7 day. So at 8 day, at 9 day, at 10 day is all different. So we are finding the gradient at one specific point. Okay, one specific point. So part D, Elizabeth wishes to estimate what is the mass of the baby when it's 1 year old. She proposed to extend the line, okay, until t equals to 365. Explain why this is not possible. Why is this not possible? Is because the rate of growth, okay, the rate of growth, okay, may be different. Okay, may be different. Okay, because you don't know how would it go after this, right? After this. Okay, so the rate of growth may be different. Okay, when the rate of growth may be different outside the recorded mass, as it is not a linear graph. Okay, it's not linear, so we cannot estimate. We really cannot estimate. So it is not a good way to just draw a line and then say, because the baby don't grow proportionally to the number of days. Okay, so it fluctuates. Is that clear? So this is the whole question. Got it? Okay. So you do your own